Number one, solve tangent to x minus 5 equals 1 for x interval 0 to 180. Okay. Tangent to x minus 5. I'm going to convert 1 into tangent 45. So it becomes 2x minus 5 equals 45. So 2x equals 50 because 45 plus 5, and x equals 25. Okay. And according to this requirement, this information that x interval from 0 to 180. So this is 0 to 180. It means from the first quadrant to second quadrant. If 25 here means as well plus 8 plus 1 plus 90, I mean plus 90. So there are two angles, 25 and 25 plus 90, 115. Yeah. So at the first quadrant and the second quadrant. So x are 25 and 115. Two, solve 3 multiply 9 power x plus 5 multiply 3 power x minus 2. Okay, so let a equals 3 power x. So it means this equation becomes 3a squared plus 5a minus 2 equals 0. And the next step, factorize this equation. 3a times a is minus 1, this is plus 2. So a equals 1 over 3, or a equals minus 2. That means 3 over x equals 1 over 3, which x equals minus 1. And 3 power x equals minus 2. So it means x equals 3 log minus 2, or x equals log 3 of minus 2. Number 3, quadrilateral OABC is shown on the following set of axes. This is the diagram. Quadrilateral OABC is symmetrical about OB. OB is the symmetry of this quadrilateral. A has coordinates 6, 0. So coordinate point of A is 6, 0, and C has coordinates, this point C has coordinates point 3, 303. Write down the coordinates of midpoint of AC, right? So midpoint AC, this AC, okay. If we create the straight line, it will be like this, AC, yep. And this midpoint we are going to find, right? So A part 1. C is 3, and the coordinate point C is 3 and 3 square root 3, while coordinate point A 6, 0. So midpoint of uh, AC we can find through X and Y. So for X is 3 plus 6 over 2, 3 plus 6. And it is 9 half. While Y is 3 square root 3 minus 0. Oh, okay, this one, or plus 0. So it is divided by 2 and 3 square root 3 half. So this is also the midpoint. Midpoint is 9 half, comma 3 square root 3 half. This is the midpoint. Hence or otherwise, find the equations of the line passing through the points O and B. Part 2. So to find the equation, we need to find gradient first, y over x. So 3 half over 9 half. 3 square root 3 half times 2 over 9. It will be 3 square root 3 over 9. Or 3 or 3. That is the gradient. And there's a straight line equation like this. Y minus minus 0, 3 x minus 0. Why is 0 and 0? Because this straight line through origin. Through origin here, 0, 0 here. This straight line. Okay. So this is through 0. So it's going to be y equals 3 over 3x. This is the equation or the function. Given that OA is perpendicular to AB, OA perpendicular AB, this one. This is 90 degrees because perpendicular. Okay. And then find the area of the quadrilateral OABC. Okay. So let me at point B, we need to find coordinate point B. This point B, we need to find that according to the information that A is 6, 0. This is 6. Okay. 6. It means this is 6. Okay, now we're gonna find y how much. Okay, so y equals square root 3 over 3x according to this equation. So y equals square root 3 over 3 times 6. And it is y equals to square root 3. So the coordinate point 6 comma 2 square root 3 here. This is 2 square root 3. Now, we will find the this area of this triangle, right angle triangle. After that, times 2. Okay, I'm gonna move here. So area triangle OAB half times OA times AB, half times 6 times 2 square root 3, and it is 6 square root 3. So it means area quadrilateral. Area of quadrilateral is 2 times 6 square root 3, and it is 12 square root 3. Number 4. A species of bird can nest in 2 seasons, spring and summer. The probability of nesting in spring is k. The probability of nesting in summer is k half. This is shown in the following tree diagram. This is diagram, spring and summer. So the first nesting in spring and the second nesting in summer. Complete the tree diagram to show the probabilities of not nesting in each season. Write your answers in terms of k. Okay. So if the probability of nesting is k, it means probability of not nesting is 1 minus k. And how about this? If the probability of nesting is k half, it means the probability of not nesting 1 minus k half. As well this 1 minus k half. Complete. It is known that the probability of not nesting in spring and not nesting in summer is 5 over 9. Show that 9k squared minus 27k plus 8 equals 0. Okay. So look this probability that 1k minus 1 1k times 1 minus k over 2. Not spring, not nesting in spring and not nesting in summer. Okay, not nesting in spring, this one, and not nesting in summer, this. So that's why 1 minus k times 1 minus k half equals 5 over 9. And it is 1 minus k half minus k plus k squared half 5 over 9 times 18, and it is becomes 9k squared, 27k plus 8 equals 0. Okay. So this is the equation according to this statement. Show that 9k squared minus 27k plus 8 equals 0. Both k equals 1 over 3 and k equals 8 over 3 satisfy 9k squared minus 27k plus 8 equals 0. State why k equals 1 over 3 is the only valid solution, of course, because if k equals 8 over 3, this is 2, 2 over 3 and greater than 1. While the probability is the probability never greater than 1. So, okay, so that's why the valid solution only the valid solution this is part 2. So valid solution only k equals 1 over 3. Number 5, function f is defined by fx equals 2 times x plus 3 over 3 times x plus 2, where x real numbers. The graph y equals fx is shown below. This is a rational function. Write down the equations of the horizontal asymptote. A rational function graph asymptote, how we determine through comparing the leading terms. So if the function is y equals 2x plus 3 over 3x plus 2, multiply becomes 2x plus 6 over 3x plus 6. So how to find the horizontally asymptotes? Okay. Horizontally asymptotes, comparing this to x and 3x. So horizontal asymptote is y equals 2x over 3x. So it becomes y equals 2 over 3. So this asymptotes, horizontally asymptotes, this straight line is y equals 2 over 3. Consider gx equal mx plus 1. You write down the number of solutions to fx equals gx, which m greater than 0. So B part 1. If m greater than 0, so it means gx gx is a straight line. Gx is a straight line. Gx equals mx plus 1. If m greater than 0. If m equals 0, so gx equals 1. That is only a straight line. But if m greater than 0, it means gx is a function. Okay, a straight line, but a function. If m equals 0, gx only a constant number because equals 1. Okay, so if m, for example, if m equals 1, according to this requirement that m greater than 0, I'm going to taking 1. Okay, if uh, m equals 1, it means gx, x plus 1. Yeah. If m equals 1. The function becomes x plus 1 if m equals 1. If m equals 1, so, and if we create the strike line, there are two coordinate points to intersect point on x-axis minus 1 comma 0 and on y-axis 0 comma 1. And I will create, this is minus 1 comma 0, this is 0 comma 1. And if you create the strike line, it becomes like this. Look that there are two solutions, two intercept point between this strike line. Okay, this is the strike line of gx. Okay, gx equals x plus 1. So there are two intercept points between gx and fx. So it means there are two solutions. Okay, and the conclusion is because it has two intercept points, so there are two solutions. Okay, next. Part 3. Determine the range of values for m. Part 2, sorry, part 2. Determine the value of m such that fx equals gx has only one solution for x. Okay, so we're going to determine m. Okay, part 2, right? So fx equals 2 times x plus 3 over 3 x plus 2. Okay. While gx equals mx plus 1. So we will find this m, this gradient, how much? Okay, if fx equals gx, becomes 2x plus 3 over 3x plus 2x plus 6, I mean, over 3x plus 6, okay, equals mx plus 1. So it will be 2x plus 6 equals multiply 3x plus 6 times mx plus 1. So it becomes 3m x squared plus 3x plus 6mx plus 6. So it is 3m x squared plus 6mx minus 2x and then plus 3x equals 0. 6 and 6 cancel, equals 0. So it becomes 3m x squared plus 6mx plus x equals 0, or 3mx squared plus 6m minus plus 1, sorry, x equals 0. Right. If only has one solution, this is a quadratic equation. The quadratic equation has one solution if discriminant equals 0. Okay. If b squared minus 4ac equals 0. So this is b, c equals 0. So 6m plus 1 squared minus 4 times 3m times 0 equals 0. So 6m plus 1 squared equals 0, or 6m plus 1 equals 0. So 6m equals minus 1, m minus 1 over 6. So this is m. Next, determine the range of value for m, where fx equals gx has two solutions for x greater than or equal 0. If two solutions, it means discriminant, the discriminant greater than 0. Okay. Part C, fx equals gx becomes this one, 3m x squared plus 6m plus 1 x equals 0. So it means a equals 3m, b 6m plus 1, c equals 0. So if discriminant greater than 0, then 6m plus 1 squared greater than 0. So 6m plus 1 greater than 0. So 6m greater than minus 1. M greater than minus 1 over 6. The conclusion, m should be greater than minus 1 over 6, less than 0. Number 6, a farmer grows two types of apples, cooking apples and eating apples. The weights of the apples in grams can be modeled as normal distributions with the following parameters. For each type of apple, you can assume that 95% of the weights are within two standard deviations of the mean. Find the percentage of eating apples that have a weight greater than 140 grams. Okay. Okay. So it means I have to find the probability first and then convert into grams by table, right? A. So probability if x, okay, if this is x, if x with x apple weight 140, means we're going to find probability x greater than 140. So I will find the z first. 140 minus 100 over 20. Recall that mu equals mu of mu of this apple equals of eating equals 100. Mu eating here, and then if you look this, the standard deviations of eating 20 and mean or mu equals 100. Standard deviation 20 and x equals 140. Okay, so the formula like this to find z. So we're gonna get 40 over 20, and it is 2. And the next step, it means probability x greater than 140. It's gonna be probability that z greater than 2. This result. So if you gonna find this probability is probability z greater than or equals 0 minus probability z greater than or equal to 0 less than or equal to, and it is 0.5. And truth table, we could find 0.4772. And the result is 0.0228. In percentage becomes 2.28%. Or in another version, they convert becomes 2.5. Okay. In another version. But for me, I like to use this result from table. And B, the question is the information the farmer grows a large number of apple, which 80%. 80% are eating apples. Both types of apples are picked and randomly mixed together in a cleaning machine. After cleaning, the machine separates out those that have a weight greater than 140 grams into a container. And apples are randomly selected from this container. Find the probability that it is an eating apple. Eating apple, the probability. Give your answer in the form C over D. C over D. C over D is a fraction. So X waiting if X, oh yeah, if X is weight of cooking apples. Okay, so probability. Wait, I'm gonna check first. Are eating apples. Okay, so 80% eating a probability of cooking 140. Okay, is 140 minus 140 over 40. It is 0. Okay, so on truth table, you can find that if 0, the table shown that 0.5 or 50%. While probability of eating apple, according to the information, that 80% or 0.8. And probability of weight of eating apple greater than 140, it is 0.023. This number approximately becomes 0.023. And then probability of cooking apple, it is 1 minus 0.8. 1 minus eating apple, probability of eating apple. Yeah, so that is the probability of cooking apple, 0.2. And probability of weight of cooking apple greater than 140 is 0.5. This. Okay. Now, the probability of eating apple, while weight 140, it is the probability of eating apple times probability of weight of eating apple greater than 140 over probability of eating apple times probability of weight of eating apple, greater than 140, plus probability of cooking apple times probability of weight of cooking apple greater than 140. Based on this information, you can substitute here. It is 0.8 times 0.023. Okay, this one over 0.8 times 0.023 plus 0.2 times 0.5. And if you calculate, you can find the fraction 23 over 146. This, my calculation. See, if you have any fractions, that's according to your calculation. Number 7. A function gx is defined by gx equals this expression to cubed minus 7x squared plus gx minus e, where d and e element rational number. Alpha, beta, and gamma are the three roots of the equations, of these equations. If this equation is equal to 0, if 2x cubed minus 7x squared plus dx minus e equals 0. So it has, this equation will have three roots, alpha, beta, and gamma. Write down the value of alpha, beta, and gamma. Okay, I'm gonna writing here the solution. Uh, this is the quadratic equations. If 2x cubed minus 7x squared plus dx minus e equals 0, this is a quadratic equation. And according to Vieta theorem, that uh, its roots, okay, alpha, beta, and gamma, if alpha plus beta plus gamma, it equals minus b over a. This is a equals 2, b equals minus 7, c equals d, and d equals e. So it means it is minus of minus 7, so 7 over 2. So alpha plus beta plus gamma equals 7 over 2. Okay. Next, a function hc is defined by hc equals this expression, 2z, 2z power 5 minus 11z power 4 plus rz cubed plus sz squared plus tz minus 20. Rc and t, element of rational number, alpha, beta, and gamma, are also roots of the equation. So these functions, if the equations equals 0, it has roots alpha, beta, and gamma. It is given that hc equals 0 is satisfied by the complex number z equals p plus 3i. So it means the roots of these functions of hc, this equation equals 0, are alpha, beta, gamma, p plus 3, p plus 3i, and p minus 3i. Why? Because p plus 3i and p minus 3i are are always be the complex conjugate pair. So the complex conjugate pair. Okay, so p plus 3i and p minus 3i are always be the complex conjugate pair on a functions involve the complex number. Because this, according to information, that these functions involve the complex number. Okay, so there are the roots of this equation, hc equals 0. Now the equation show that p equals 1. B. P equals, we are going to prove that P equals 1. So according to Vieta theorem, that the roots alpha plus beta plus gamma plus P plus 3i plus P minus 3i, it equals minus B over A, according to Vieta theorem. So 3 minus 3, 3i minus 3i. And the previous solution, that alpha plus beta plus gamma equals 7 half. Okay, so Okay. Alpha plus beta plus gamma equals 7/2. Okay. 7/2 plus 2p equals minus b over a equals 11 over 2 because minus of minus 11. So actually, if you would like to expand this, it will be alpha plus beta plus gamma plus 2p equals minus of minus 11 half this. And recall that alpha plus beta plus gamma equals 7 half. So it means 2p equals 11 half minus 7 half. And 2p equals 4 over 2 equals 2. P equals 2 over 2. It equals 1. So P prove that it equals 1. It is now given that h/2 equals 0 and alpha beta element of positive integer alpha less than beta gamma also element of this number, rational number. Find the value of the product alpha multiply beta. One, this function hc or h/2, okay, equals 0. If h/2 equals 0, it means half is a root of this function. Okay, if half is the root of the function, it means I would like to use gamma is equals alpha and others roots are alpha and beta. Okay, so uh, according to Vieta theorem, that is alpha times beta times gamma. All roots if multiplied, okay, p plus 3i times p minus 3i, it equals minus f over a. This according to Vieta theorem on a quintic function or quintic equation. Okay, so these are the roots alpha, beta, gamma, p plus 3i, p minus 3i. If all roots multiply, it equals minus f over a. Minus f is 1 minus 20, so minus of minus 20 over 2. So it's going to be alpha times beta times half because gamma is half, okay, times p squared minus 9, oh, plus 9 because I squared equals minus 1. So it equals 20 over 2. And recall that p equals 1. It means this p equals 1, so alpha beta 10 times half equals 5. It equals 10. Okay, so alpha times beta equals 10 over 5 equals 2. This is alpha times beta. Next, write down the value of alpha and the value of beta. We are looking for, we are figure out how much alpha, how much beta. part 2. I'm going to use in the different color. Okay. Okay, part 2. According to this statement, the previous statement that hmm, alpha plus beta plus gamma plus 2p, it equals 11 half. Okay, so alpha plus beta plus half. Okay, because this one, gamma equals half plus 2 times 1, p equals 1. It's not p equals 1. This, if I'm going to show you p equals 1, so plus 2 equals 11 half. So alpha plus beta, it equals 11 half minus 2. So alpha plus beta, 10 divided by 2, 5 minus 2 equals 3. Okay, alpha plus beta, it equals 3, or alpha equals 3 minus beta, right? According to the previous information that alpha times beta equals 2. Alpha times beta equals 2. So alpha is 3 minus beta. 3 minus beta times beta, it equals 2. So 3 beta minus beta squared equals 2, or beta squared minus 3 beta plus 2, it equals 0. We factorize this beta. It is, yeah, number are minus 1, minus 2. So beta equals 1 or beta equals 2. Next, I'm going to move here. So if beta equals 2, if beta equals 2, it means alpha equals, I'm going to show you this alpha equals 1, 3 minus beta. So alpha equals 3 minus 2. It equals 1. So look that alpha less than beta. If beta equals 1, so alpha equals 3 minus 1. It equals 2. It is alpha greater than beta. This information tell us that alpha should be less than beta. So we receive this solution. So the solution is alpha equals 1 and beta equals 2. A. Use L'Hopital's rule to find limit x approach to 0, secant power 4x minus cosine square x over x power 4 minus x squared. Right. According to L'Hopital's rule, that we have to find the derivative of numerator, derivative of denominator. After that, substitute x equals 0 until we find the solution. Right. The first step, I'm going to find the derivative of numerator and derivative of denominator. Okay. So derivative of secant power 4x, I already find it. That is 4 second power 4 x tangent x. Okay, minus derivative of cosine squared x. That is minus 2 sine x cosine x. And derivative of x power 4 minus x squared is 4 x cubed minus 2x. Next, if you substitute 0 into this fraction, into this expression, you will find that the denominator is 0. Okay, and a number divided by 0, the result will be undefined. So it means we have to find the next derivative of numerator and denominator. So it will be limit approach to 0. Now, the derivative of 4 second over x, tangent x. Okay, I would like to writing uh, uh, that is 4 second power 6x plus 16 second power 4 x tangent squared x minus derivative of minus 2 sine x cosine x is 2 sine squared x minus 2 cosine squared x. And derivative of denominator, 4 times 3, 12, x squared minus 2. Now, if we substitute 0 to this fraction, 4 times second 0 power 6, it will be 4. And this is 0 minus this part as well, sine 0 equals 0 minus this is 2 over this is 0 minus 2 will be 4 plus 2 over minus 2. It is 6 over minus 2 plus minus 3. This the solution, minus 3. Number 9. A teacher takes n students on a field trip. The students are assigned randomly into 2 groups. For a safety reasons, there must be exactly 3 students in the first group and at least 3 students in the second group. The teacher will randomly assign 3 students to the first group and other students to the second group. So 3 students at the first group and the rest on the second group. Write down an expression for the number of ways that the students could be assigned. So it means this is a combination. This is about combinations of n students, okay, n students, and the ratio is 3, okay, because 3 is 3 students in the first group and others are the second group. Two of the students asked the teacher not to work in the same group. The teacher agrees and now finds that the number of ways to assign the students is half. So number of ways assigned to the students is half. Okay, sorry, half. Okay. Determine value of n. So this is part A and part B. This one. And I will begin with number of ways. Number of ways to assign two students. It is in combination 2 with ratio 1. And after that, the number of ways okay, uh, to assign others, okay, assign other students, uh, assign other students to have one group, of three. Mm. And that is the combinations of others is n minus 2. N minus 2 with ratio 2. Next. Means to calculate that's a combination n, a combination n with ratio 3, it equals because of two groups. So it's going to be 2 times this combination times this one, n minus 2, 2. So these combinations in factorials we can writing n factorials over 3 factorials n minus 3 factorials equals 2 times 2 factorials over 1 factorials, 2 minus 1 factorials times n minus 2 factorials over 2 factorials n minus 2 minus 2 factorials. So next is n factorials over 6 because 3 times 2 times 1 n minus 3 factorials, sorry, 3 factorials. It is 2 times, wait, yet because divide, and this is 1. Okay, so 2 divided by 1 equals 2. And then it is n minus 2 factorials. And then n minus 4 factorials. And after that, this n times 2, but I will expand n factorials becomes n times n minus 1, n minus 2, n minus 3 factorials over n minus 3 factorials. 6 times 2 equals 12. And then I will expand as well, n minus 2, n minus 3, n minus 4 factorials over n minus 4 factorials. So equals 1, divide. Also divided. It's going to be, wait, equivalent, right? Okay, so it's going to be n times n minus 1, n minus 2, 12, n minus 2, n minus 3 equals 0, equals 1, I mean, and then multiply n squared minus n equals 12n minus 36. It's going to be n squared minus 13n plus 36 equals 0. Factorize. Minus 9, minus 4. Okay. So it becomes n equals 9 or n equals 4. But we receive this solution n equals 9. Why? Because when the teachers divide their groups, okay, look that the 3 students in the first group and at least 3 students in the second group. It means over than 4. Impossible 4. So the solutions n equals 9, not 4. And consider the arithmetic sequence APQ, where A, P, and Q unequal 0, so that to P minus Q equals A. Okay. A, the arithmetic sequence A, P, Q, so on. And the common difference is D equals P minus A, the second term minus the first term, okay, or 2D, to common difference equals Q minus A, okay? So D equals P minus A, it means 2 times P minus A equals Q minus A. Then to P minus 2A, Q minus A. So to P minus Q equals to A minus A. Then what over here? To P equals, to P minus Q, I mean, sorry. To P minus Q equals to A minus A. It is A, or A equals to P minus Q. Yeah. Correct. Okay. And this is the first equation, or this one. A equals to P minus Q. And next, consider the geometric sequence AST, so that S squared equals AT. AB, the geometric sequence A, S, T, so on. R equals S over A. R squared equals T over A. Okay. And then it is R squared equals S squared over A squared. So R squared equals R squared. So S squared over A squared equals T over A, or S squared equals T over A times A squared, or S squared equals T A. This is the second equation. A proof that S squared equals AT. The first term of both sequences is A. Okay? It is given that Q equals T equals 1. Show that P greater than half. P is greater than half. Okay, see? The arithmetic sequence. If Q equals T equals 1, it means the arithmetic sequence being A, P, 1, so on, because T equals Q equals 1. And as well, geometric sequence, it is equals A, S, 1, so on. From the first equation, A equals to P minus Q, or minus 1, because Q equals 1, minus 1. Okay? This is the first equation. Okay. A equals to P minus 1, to P minus Q, and it becomes to P minus 1. And then uh, from the second equation, that A equals S squared, this one. Yeah, if T equals 1, it means S equals, A equals S squared. Okay, because S squared equals AT, and T times 1, 1 times A equals A. So it means A equals A, so S squared equals 2P minus 1. So S equals square root 2P minus 1. Now look here. This is the important notes for us, that if S equals square root 2P minus 1, the implication to P minus 1 should be greater than 0. Why? Because to P minus 1, because to P minus 1 cannot less than 0. Why? If it less than 0, S will become the imaginary number, okay? Because square root negative, square root minus a number. So 2P minus 1 cannot less than 0. It should be 2P minus 1 greater than 0. If 2P minus 1 greater than 0, it means 2P greater than 1. and p greater than half based on this equation C. Next, consider the case where a equals 9, s greater than 0, and q equals t equals 1. Right. Okay. Write down the first four terms, of arithmetic sequence of geometric sequence. Okay, part 1. A equals 9, q equals t equals 1, and s should be greater than 0. Okay, from this equation, or this one, I mean, from this equation, a equals to p minus 1. If a equals 9, it will be 9 equals to p minus 1. And it means to p equals 10, and p equals 5. Okay. If p equals 5, the arithmetic sequence A, P, Q, and so on becomes the arithmetic sequence 9, 5, because P equals 5, Q equals 1, and of course this is minus 3. Okay, because the common difference is a minus 4. Okay. Next, part 2. Part 2 from this equation, this one. Okay, this a equals s squared. So 9 equals s squared. So s equals square root 9, and it is 3. So it means the geometric sequence a, s, t, so on becomes 9 because a equals 9, s is this one 3, t is 1, and look, the ratio is 1 over 3. Okay, so it means the fourth terms is 1/3. Done. The arithmetic and the geometric sequence are used to form a new arithmetic sequence un. Okay, the first three terms of un are the first term 9 plus ln 9, the second term 5 plus ln 3, and the third term 1 plus ln 1. Find the common difference of the new sequence in the terms of ln 3. Okay, so this is part 1. Uh, the, the, first, the first term is 9 plus ln 9. And the second term is 5 plus ln 3. And the third term is 1 plus ln 1. So common difference equals the second term minus the first term, 5 plus ln 3 minus 9 plus ln 9. So it's going to be 5 plus ln 3 minus 9 minus ln 3 squared. 5 minus 9 minus 4 plus ln 3 minus 2 ln 3. And it is minus 4 minus ln 3. So this is the common difference. Okay, and the part 2 is show that sigma I equals 1 till 10 of ui equals minus 90 minus 25 ln 3. It means we are going to find Sn or S10. We're going to find this because of sigma. Sigma is accumulation, okay. And part 2, so Sn is n half times 2a plus n minus 1 times d. So if S10, it means 5, 10 divided by 2. A equals 9 plus ln 9. I'm going to show you this. This is the first term, so the second term, and the third term. And plus n minus 1, it means 9. 9 times the common difference minus 4 minus ln 3. Okay, so 5, 18, 2 times 9, plus 2 ln 9, I will convert into ln 3 squared plus being minus because 9 times minus 4, 36, 9 ln 3. Okay, so 5, 18 and minus 36 minus 18, and 2 times 2 is 4 ln 3 minus 9 ln 3. So 5 times minus 18 minus 5 ln 3 is equals 5 times minus 18 minus 90 minus 25 ln 3. This one. 11. The plane pi 1 has equation 2x plus 6y minus 2z equals 5. A, verify that the point A, 2, half, and 1 lies on the plane pi 1. Okay. A, plane pi 1 to x plus 6y minus 2z equals 5. Okay. Through a coordinate point A, 2, half, and 1. So substitute this coordinate point into this plane becomes 2 times 2, 6 times half, 2 times 1. And it equals 4 plus 3 minus 2. Okay, because 2 times 1. It equals 5. Proof that it is 5. So it means based on the question, coordinate point A lies on plane pi 1. So coordinate point A lies on pi 1. B. The plane pi 2 is given by this equation where P, Q, K element real and P unequal 0. In the case where P equals minus 6, pi 2 is perpendicular to pi 1 and A lies on pi 2. Okay, find the value of K and the value of Q. I'm going to start with dot product. That's dot product of plane 1 and plane 2 equals 0. Yeah. So it means x1, y1, z1 times x2, y2, and z3, c2, I mean, it equals 0. So it means x1 times, x1 times x2 plus y1 times y2 plus c1 times c2 equals 0. So plane pi 1 plane pi 1, this is x2. Plane pi 1 is 2x plus 6y minus 2z equals 5. Look that the coefficients of x equals 2, coefficient of y equals 6, and the coefficients of z equals minus 2. Plane pi 2 is k squared minus 6, x plus 2k plus 3, y plus pz equals q. And now we are going to multiply based on this rule. Okay, this is the x1, x2, y1, y2, z1, z2. So it's going to be 2 times k squared minus 6 plus 6 times 2k plus 3 minus 2 times p equals 0. Then 2k squared minus 12, 12k plus 18 minus 2p equals 0. And according to that information that P equals minus 6. Okay, P equals minus 6. So it becomes 2k squared uh, plus 12k. Then 16 minus 12 is 6 plus 12 comes to k squared plus k plus 18 equals 0. Or it equals divided by 2, k squared 6k plus 9 equals 0. After that, factorize because we're going to find k plus 3 plus 3. K equals minus 3. After that, substitute into plane k. K squared minus 6 x plus 2k plus 3 y plus pz equals q. True. Two, half, and 1. So becomes 9. 9 minus 6 x. X equals, this is 2, okay, times 2. I mean, plus 2 times 3 minus 6 plus 3 times half, and then plus p equals minus 6. Minus 6 times z equals 1. Equals q. Q equals, if you calculate it, q equals 6 minus 3 half minus 6 plus 3 half. This is q. And the next, for part C, D, and E, it is now given that pi 2, plane pi 2 is parallel to pi 1. Plane pi 2 parallel with plane pi 1 with k equals 3. Determine the value of p. Let's see. Plane pi 2, plane pi 2 parallel to pi 1 with k equals 3. Right. We are going to using a rule that first factor is multiply of the second factor. Yeah. So pi 1 is 2, 6 minus 2, while pi 2 is 9 minus 6, 2 times 3 plus 3, sorry, plus 3, and then p. Okay. this is the coefficient. This is the coefficient of plane pi 1. This coefficient of plane pi 2. Okay. So 2, 6n minus 2 plane pi 1 it equals mu times 3, 9, and p from this matrix. So it means 3 mu equals 2. So mu 2 third. Okay. And now this one mu p. So mu p it equals minus 2 based on this equation. So 2 over 3p equals minus 2. P equals minus 2 times 3 half. So it is minus 3. So P equals minus 3. Okay, according to plane D1, P equals just now minus 3. Now, it is also given that Q equals minus 51 over 2. The line through A that is perpendicular to plane pi 1 meets plane pi 2 at the point B. Find the coordinates of B. D part 1. The Q equals minus 51 over 2, and then A 2 half and 1 perpendicular uh, perpendicular to plane pi 1 and meets to plane pi 2 meets plane pi 2 at coordinate point B. So a line through A, we are going to find a line which is through A perpendicular to plane pi 1. And then if the coordinate point B, we find coordinate point first, and then after that we are going to find the line. If B equals X, Y, and Z, so it equals 2 half 1 plus lambda times 2, 6, and minus 2. So it is 2 plus 2 lambda, then half plus 6 lambda, and then 1 minus 2 lambda. And then the substitute, this result substitute into plane pi 2. So it's going to be 10 pi 2. It's going to be k squared, plane pi 2 minus 6x. I'm going to writing this first. This x, y, z. So it becomes, this is q. Q equals k squared minus 6 times 2 plus 2 lambda. 9 times half plus 6 lambda. Okay, and then minus 3 times 1 minus 2 lambda is equals minus 51 half. It's minus 51 half. And it becomes 6 plus 6 lambda. 9 half plus 54 lambda minus 3 plus 6 lambda equals 51 over 2, minus 51 over 2. And then multiply by 2, it is 12 plus 12 lambda plus 9, 108 lambda minus 6 plus 12 lambda minus 51. And after that, it becomes, calculate, it's going to be 132 lambda equals minus 15. So lambda minus, sorry, 51 minus 51 minus 15. So minus 51 minus 15, it is minus 66 actually. So lambda equals minus 66 over 132 or minus half. So B is 2 plus 2 times minus half, and then half plus 6 times minus half, and then 1 minus 2 times minus half. So B, coordinate point B is 1. And then this calculation minus 3 minus 5 half. Minus 6, yeah. And then 2. Yeah. That is coordinate point B. One. And show that the perpendicular distance between plane pi 1 and plane pi 2 is square root 11. Okay, so part 2. A is 2 half 1. B is 1 minus 5 half 2. Okay, so AB equals square root 2 minus 1 squared plus half minus 5 half squared 1 minus 2 squared is 1 plus 9 plus 1 is equals square root 11. Yeah, proof. What else? E, find the equation of a third parallel plane pi 3, which is also a perpendicular distance from square root 11. Perpendicular distance of square root 11 from pi 1, plane pi 1. Okay, E. So the information says that the perpendicular pi 1, the equation, okay, perpendicular to pi 1, okay, which is pi 1 is 2x plus 6y minus 2z equals 5. Again, I'm going to remind you that the coefficients of x equals 2, coefficients of y equals 6, and the coefficients of z equals minus 2. And the coordinate point on pi 3, the coordinate point on pi 3 is 1 and as well minus uh, minus 5 and then 2, 2, 6 and then minus 2. Okay. This is minus 5 half. So it becomes 3, 3 half, and then 0 because 2 minus 2. Now, these values of x, y, z, this coordinate point, substitute into plane pi 3. X plus 3y minus z equals d. Coefficients of x is 1, coefficients of y is 3, coefficients of z equals minus 1. So if we substitute this coordinate point, it's going to be 1 times 3 and then plus 3 times 3 half, 0 times minus 1 becomes 3 plus 21 half. And it is 27 over 2. So the equations of plane 3, the equation of plane 3 is x plus 3y minus z equals 27 over 2. A, let fx equals 1 minus ax power minus half, where ax less than 1. The n derivative of fx is denoted by f power nx, proved by induction that f power nx equals this expression, a power n times 2n minus 1 factorial times a power ax power minus 2n plus 1 over 2 over 2 power 2n minus 1 times n minus 1 factorials. Okay. According to induction, mathematics how to prove that the first step, we need to state that true for the number n equals 1. So the first step, uh, there are two steps for this part. You look this function that actually I would like to say that this is the left side and this part is for this expression is the right side. Okay, identify. Okay, so for left side, fx is equals 1 minus ax power minus half. And it means for the derivative of this function is minus half times 1 minus ax power minus 3 half times minus a. So minus times minus is positive. Half a times 1 minus ax power minus 3 half. Okay, and the second part is the right side. The right side is 1. Now, okay, this expression, this equation, I mean, that f power nx equals a power n times 2n minus 1 factorials times 1 minus ax power minus 2n plus 1 over 2 over 2 power 2n minus 1 n minus 1 factorials. This is the right side. And for the derivative, according to the rules that f1, so f1, it means n equals 1. So a power 1, 2 minus 1, because 2 times 1 so equals 1. Factorials 1 minus a x power minus 2 plus 1 over 2. 2 times 1 equals 2 power 2 minus 1 times 1 minus 1 factorial. Because n minus 1. N is 1. It equals a times 1. This 1 factorial equals 1. 1 minus ax power minus 3 half over this is 2 power 1 times 1. It equals 2. And it is half a 1 minus ax power minus 3 halves. Now look that this expression, okay, same with this expression. Okay, so prove that this statement is true for number n equals 1. So we can say that the left side equals right side. So the conclusion, so it's true for n equals 1. And the second step, it is true for, it is true for n equals k. Okay. So if n equals k, based on this function, that f power k equals a power k times 2k minus 1 factorials 1 minus ax, or here x, minus 2k plus 1 over 2 over 2 power 2k minus 1 k minus 1 factorials. Okay, I need more space. So the derivative of this function, derivative, it is minus 2k plus 1 over 2, and then times minus a, okay, because this derivative of 1 minus ax. And after that, a power k, this one, a power k, and then root k minus 1, 1 minus ax, this factorial, minus 2k plus 1 over 2 minus 1. And that is the derivative. Okay. Oh, it's over. Sorry, over 2 power 2k minus 1 times k minus 1 factorials. All right. So we continue here. And it's gonna be times, so a times 2k plus 1 times a power k to k minus 1 factorials 1 minus ax power minus 2k plus 3 over 2, because this is minus 1. Minus 1, if minus 1 becomes 2 over 2, it's going to be 2k plus 3. Okay. Hopefully you understand that. And for this part, this expression, this term, it becomes 2 power 1, this power 1, times 2 power 2k for this term, 2 power minus 1, and then k minus 1 factorials. It becomes 1. So it's going to be a power k plus 1 times 2k times 2k plus 1 times 2k minus 1 factorials, then times 1 minus ax power minus 2k plus 3 over 2 over, it's already 2 times 2 power 2k, okay, and then k times, oh wait, I forgot that for this part I will multiply by 2k over 2k, especially for uh, this fraction, this term. And if you multiply by 2k over 2k, okay, so this 2k is this one here, and 2k is going to be it's going to be here, k times k minus 1 factorials is 2k. 2k is from this 2k, right? It becomes a power k plus 1 to k plus 1 times 2k times 2k minus 1 factorials times 1 minus ax, okay? 2k plus 3 over 2 over this part. So it becomes 2 times 2k plus 1 because this is 2 power 1. So it's going to be 2 power 2k plus 1. And for this expression, this is k factorials. K factorials is k times k minus 1 factorials. So it's going to be a power k plus 1 then times 2 2k plus 1 factorials. After that, 1 minus ax power minus 2k plus 3 over 2 over 2 power 2k plus 1 times k factorials. Okay. So this is if n equal k. All right. So this is the derivative of f power k x over dx. And the third step is true. This is true. Okay. And then the third step true for n equals k plus 1. So f and f power n x equals a power n to n minus 1 factorials 1 minus ax power to n plus 1 over 2 over 2 power to n minus 1 times n minus 1 factorials. If n equals k plus 1, if n equals k plus 1, it means f k plus 1 x, it is a power k plus 1 times 2k plus 1 minus 1 factorials times 1 minus ax power minus 2k plus 1 plus 1 over 2 over 2 power 2k plus 1 minus 1 times k plus 1 minus 1 factorials. It equals a power k plus 1 times 2k plus 1 factorials 1 minus ax power minus 2k plus 3 over 2 plus 3 because 2 times 1 plus 1 over 2 power 2k plus 1 k factorials. So if you compare, I'm going to using the different color, this one or this one. Okay, if you compare this part, okay, same with this part. Okay, so true for n equals k plus 1. So prove that yeah, now proof by induction. Proof by induction that f power n x equals a power n times 2n minus 1 factorial 1 minus ax power minus 2n plus 1 over 2 over 2 power 2n minus 1 times n minus 1 factorials. D, by using part A or otherwise show that the Maclaurin series for fx equals 1 minus ax power minus half up to and including the x squared term is 1 plus half ax plus 3 over a squared x squared. Okay. Okay, I'm going to use this space. Part B. Fx at left side, fx equals 1 minus a x power half, power minus half. This the left side. So if f 0, it means 1 minus 0 power minus half, it equals 1. Okay. And according to the rules that if we would like to find the derivative, we have to using these rules, f power n x equals a power n to n minus 1 factorials times a minus ax power minus 2n plus 1 over 2 over 2 power 2n minus 1 n minus 1 factorials. So it means the first derivative is f power 1 x a power 1 2 minus 1 factorials 1 minus ax power minus 2 plus 1 over 2 over 2 power 2 minus 1, 1 minus 1 factorial. It's going to be 8 times 1 minus ax, power minus 3 half over 2 times 1. It becomes half a times 1 minus ax, power minus 3 half. According to Maclaurin series, that the next step is x times reverse the derivative, but x becomes 0. So it becomes x times this expression, but x equals 0, half a1 minus 0 minus 3 half is equals half ax. And the second derivative, f power 2 x. The second derivative is a squared, a power 2, 4 minus 1 because 2 times 2 minus 1 factorial, 1 minus ax, power minus 5 half over 2 power 4 minus 1 times 2 minus 1 factorial, and it equals this a squared, a times this is 3 3 factorial, it means 6 a squared, 1 minus ax, power minus 5 half over 8 times 1 over 8, or 6 over 8, 3 over 4, a squared, 1 minus ax, power minus 5 over 3. And the next step, according to Maclaurin series rules, that the next step is x squared times f power 2, 0. So x squared times 3 over 4, a squared, 1 minus 0, power minus 5 over 3. So it is 3 over 4, a squared, x squared. So the expansion becomes, becomes 1, and the next is this half. I'm going to use in a different color. So the expansion becomes 1 half ax, and this one. Yeah. So 1 plus half ax plus 3 over 4 a squared x squared, not 3 over 8, but 3 over 4 plus so on. Next, part C. Hence, show that 1 minus 2x power minus half times 1 minus 4x power minus half equivalent with 2 plus 6x plus 19x squared over 2. Okay. Part C. So if fx equals 1 minus 2x power minus half, it means f0 is 1 minus 0 power minus half is equals 0. Okay, so f, the first derivative, equals the first derivative is this is 1 according to the rule that it becomes half times 2. Okay. 1 minus 2x power minus 3 half. Okay, it equals 1 minus 1, 1 times 1 minus 2x. This. And according to Maclaurin series, that x times the first derivative 0. So x times this is 0. It means 1. Yeah, so it equals x. And the second derivative, f over 2x, it equals 3 over 8 times 2 squared, 1 minus 2x power minus 5 half. And it becomes, this is 4, okay, 4, so 3 half. 1 minus 2x power minus 5 half, according to Maclaurin series rules, it becomes x squared times f0 of the second derivative, so x squared times 3 half, 1 minus 0. Is x squared times 3 half, 3 half x squared. Okay. So the expansion becomes, I'm going to write it with the different color. The expansion becomes 1 plus x plus 3 half x squared, so on. And the next is fx, or fx equals 1 minus 4x power minus half. So according to this information, that 1 minus 2x and 1 minus 4x. So f0 equals 1, of course, and then the first derivative, f power 1, x is 4 times 1 minus 4x power minus 3 half over 2. Yeah. So it's going to be 4 divided by 2, 2 times 1 minus 4x power minus 3 half. And according to Maclaurin series, that x times the first derivative, x becomes 0. X times this x equals 0. 2 times 1, 2x. And the second derivative, is 3 over 8. Yeah, 3 over 8 times 2 squared. Okay. So 4 squared, sorry, times 4 squared. This is 4. Okay. Wait. 1 minus 4x power minus 5 half. And then this is 16 divided by 2. Yeah, 6 here. Because 2 times 3. 1 minus 4x. Okay, power minus 5 over 2. And x squared, according to Maclaurin, this is x squared 6, 1 minus 0. And it becomes 6x squared. So the expansion becomes one. This 1 and 2x and 6x squared. 2x, 6x squared on. So it means 1 minus 2x power minus half times 1 minus 4x power minus half is equals, wait, I'm going to look the expansion first. The first expansion this, the first expansion, and then the second expansion this. So the first expansion, 1 plus x plus, wait, I need more space. 1 plus x plus 3 half x squared times the second expansion this 1 plus 2x plus 6x squared. And then it's going to be, if you multiply, becomes 1 plus 2x plus 6x squared plus x plus 2x squared plus 6x cubed plus 3 half x squared plus so on, and becomes 1 plus 3x plus 19 over 2x squared, because 6, 2, and 3 half. Okay. It becomes, this is 2 over 2, 6 over 2, 19 over 2x squared. So it becomes 2 plus 6x plus 19x squared over 2. This part C. Based on this statement. Part D, given that the series expansion for 1 minus ax power minus half is convergent for ax less than 1. State the restriction which must be placed on x for the approximation this expression to be valid. Okay. According to the statement that 1 minus 2x power minus half times 1 minus 4x power minus half, same with 2 plus 6x plus 19x squared over 2. Okay. So I would like to convert this becomes this fraction like this, 1 over square root 1 minus 2x times 1 over square root 1 minus 4x. Okay. So if convergent, yeah, it means, sorry, I will change with this one minus 2x, 1 minus 4x. Okay. It's convergent, it means uh, the denominator, this, it should be greater than 0. Okay, so 1 minus 2x, 1 minus 4x should be greater than 0. Okay, if less than 0, uh, it will uh, it will not convergent. Okay, it becomes minus an imaginary number. Yeah, we're not convergent. So it means there are two possibilities of x, that 1 minus 2x equals 0, and it means for x equals half and x equals quarter. So if we create the number line, this is a third, this is half, and if the statement inequality is like this, it means uh, the area is under the quarter. So it means that x should be less than quarter this. Use x equals 1 over 10 to determine an approximate value for square root 3. Give your answer in the form C over D. D is C and D are integer. Okay, so part E. I'm going to writing this just now. I have explained 1 minus 4x. Okay, equivalent of or same with 2 plus 6x plus 19x squared over 2. Okay, but I'd like to writing becomes 1 over, just now I have explained, 1 minus 2x, 1 minus 4x. Okay, and this is same with 2 plus 6x plus 19x squared over 2. So this term is I name as the left side, and this term or this expression is right side. Now I will substitute. Okay, substitute 1 over x equals 1 over 10 into left side. Okay, into left side, and it's going to be 1 over the root 1 minus 2 over 10, 1 minus 4 over 10. And it becomes 1 over square root 1 minus 1 over 5 should be 4 over 5. Okay, times 1 minus 4 over 10, it means 6 over 10, 3 over 5. So it's going to be 1 over square root 12 over 25, or square root 25 over 12, 5 over 2 square root 3. Okay, this for the left side. Next, for the right side, substitute also x equals 10 into right side. Okay, x equals 1 over 10. So the right side is 2 plus 6x plus 19x squared over 2. So it is going to be 2 plus 6 times 1 over 10 plus 19 times 1 over 100 over 2. And it is 200 over 100 times 60 over 100, 19 over 100. Okay, over 2. And it's going to be 269 over 100 times 1 over 2. So 269 over 200. So left side, same with right side. Left side, this one, 5 over 2 square root 3. 5 over 2 square root 3, same with 269 over 200. I would like to multiply by 2 over 5. If you multiply, it's going to be 1 over square root 3, same with 538 over 1,000. Okay, so it becomes, it's going to be square root 3, the opposite, 1,000 over 538. So square root 3, same with divided by 2, 500 over 269.